This is Algebra 1, Term 5, Lesson 2, Functions Rewind. We'll begin in Desmo's classroom doing average rate of change with square root functions. We'll do a little bit of transformation of square root functions, and then we'll come back to slides to work on a graphic organizer for the 5 parent functions. We'll then do a Edpuzzle, reviewing function notation, and then we'll finish it up with some analysis of functions. So the Desmo's classroom activity is pretty short. It's only got 14 screens, and I would say this will take about half your time. So let's take a look. The first thing they're given is a scenario with a function for the volume of water in a tank. They will use function notation to evaluate v of 0 and then explain what it means in context. In this case, they're taking a point that's represented in a graph and they're converting that into function notation, and then they're going to explain what that point reveals in this context. At this point, they're talking about increasing at a constant rate. So students are reviewing concepts they should already know. There's really nothing new in this activity. It's just that we're applying the same things we've learned in the past with the square root function. Here we have a square root function, and we will evaluate for different values of x to complete the table. And here we'll find the average rate of change over an interval of time. In this case, we're given a different function, and they're asked to find v of 0, which is our y-intercept, and v of 100, and explain what each of those reveal in this context. Here they're being asked which of these expressions represents the average rate of change over the interval 0 to 100. They will use the same points they had in the last screen. Here they're given a table that's completed for a different tank again, and they're asked to find the average rate of change over the interval 0 to 16. So instead of using the equation, they are now using values from a table. And then finally, they have a card sort activity. There are 3 functions here, so they will do 3 graphs, match those with 3 equations, and then the description about the average rate of change over an interval. The last part of this activity is revisiting transformations of functions. We're just doing the same thing we've done before with square root functions. We even did this yesterday. So here on this first one, they are describing the transformation for each of these functions. On the next screen, they're going to create an equation for this function. They should know y is equal to the square root of x is the initial equation. That is your parent. So they would transform the parent. And again, they will match the graph by creating an equation for the function. And again. And then at the end, they're going to create an equation of a square root function so that it will capture all of these stars. So reviewing what we did yesterday and reviewing what we've done a lot this year, which is transform parent functions. So on this screen, they're asked to paste a copy of their completed graphic organizer. And I'm giving you a link to these parent functions in a Google Doc. So here's what it will look like. When they come in, they will just see these. These are equations, and these are domains and ranges. These are not matched. They are all mixed up, so they need to decide which domains go with which ones. And then they're going to come down here and they're going to fill this out. Now, they will not do this digitally. This is one of those cut and paste activities. I mean, I guess you could give it to them digitally. They could go over there and copy these into these spaces if that's what you want. But my goal was to get them to manually create these graphs, like with pencil or markers on the actual graph. So this is really the first time they've hand graphed any of this stuff. We've been doing it online all year long, so this is where we're going to see if we can do it on pencil paper, since they are expected to be able to sketch these graphs on with pencil and paper. It does get a little messy, but to be honest, it's kind of a fun activity, and some of my students really enjoyed creating these. I even had them use bright colored cardstock, and then they kept those in their binders or in their backpacks, and they used those for references. They were doing the next part of their assignment, so this was a handy tool for them. You may wonder, why in the world would you wait to the very end of the course to create this parent function graphic organizer? Shouldn't we have done this at the very beginning? Well, from my experience, they are just not familiar enough with the functions at that point at the beginning of school, and I just feel like we're wasting a lot of time. At that point, they're just doing the work, but they're not really understanding it or making sense of it. So I'd rather do it as a summative activity where they kind of sum up all the different functions that they've already learned. And it's not the end of the semester. We're going to be using these parent functions for quite some time. We've got almost 2 terms to go. So we'll use this. This will be useful, but it's also more meaningful for them to create it after they have some basic understanding of what each of these parents are doing. Once they've pasted a copy of their parent functions, we're going to take a little diversion over to Edpuzzle. In the function machine, we input values for x and output values for y. In this machine, we'll input the values for x. Those will be multiplied by 2. 5 will be subtracted from that, and the output will be the y value. In function notation, the same is true. We will input values for x, and it will output values for f of x. F of x will equal 2x minus 5. We still are multiplying our variable by 2 and subtracting 5, but instead of using a second variable, we use the same variable with the function notation f. Let's look at a real-life example. Height is a function of time. A plant is 3 inches tall and grows at a constant rate of 0.25 inches per week. So notice it starts at 3 inches. After 1 week, it's grown to 3.25 inches. And after another week, it's grown to 3.5 inches. Height as a function of time is going to, in our function machine, we would input the number of weeks and output the height of the plant. If the number of weeks is multiplied by 0.25 and 3 is added to the result, the output will be the height of the plant in inches. In the language of functions, the number that's in front of the parentheses is called the name of the function. Whatever is input in the parentheses, we call the argument of the function. Sometimes those are words, phrases, expressions. And then finally, if we have f of x, x is called the variable of the function. Notice there's only one variable in function notation. F of x is 2x plus 3. That is how you read this phrase. F of 4 means input the value 4 for x and simplify to find the value for y. And in this case, the y is the f of x. F of 4 is 11. This can be represented by the order pair 4, 11. In Edpuzzle, the students will be watching the videos you just saw, but they will also be answering multiple choice questions that go beyond what's in that video. So I'll ask them to classify the function. We'll talk about, they'll identify domain, range, they'll evaluate the function. So they're doing a lot more than what you're seeing in that video. I just thought it was good to actually talk about the specificity of the terminology related to functions, because up until now they've done this stuff intuitively. We've not really talked about what this stuff means. What I'm amazed at is how well they understand this now that they've been using it all year. The last part of the activity, they're going to analyze functions, and there's going to be 4 different parent functions to analyze. Each one is a transformation of the parent. So the first thing they'll do is classify the function, then describe for me how this function is transformed from the parent. They will list out some key characteristics, and then they will write an equation and insert a screenshot of their equation for this function. So let's look at the show notes. So the speaker notes on the slide are listing out some key characteristics that they might include. Not all of the functions have all of these characteristics, so that's part of the task, is figuring out which of these apply to this particular function. But key characteristics would include things like a vertex, any of the intercepts of the graph, the x or y intercepts, maximum or minimum points, where is this function increasing or decreasing, are there any asymptotes, is there an axis of symmetry. So they're just describing those characteristics. And then I do say here the function may not have all of these. All right, the next function they're going to look at is this one. This is function 2. So again, they're going to classify it, describe it, key characteristics, and insert an equation. They will need to recreate this basically in Desmos to get that equation. And then function 3, And as you can see, all the functions are different types. You may have noticed one is missing, and we're going to use that one to allow them to create their own function. So I'm telling them to create a function that is a transformation of the parent. Y is equal to 2 to the x. Classify this function. Describe the transformation of your function. What are the key characteristics of your function? And then they will insert an equation and a graph. So that concludes Functions Rewind. We'll look at simplifying square roots a little more next time. Y'all have a great day.